Dr. Seema Wirtz, and today we will be discussing about motion of rigid bodies part 2. In this part 2, the following objectives are to be followed. First, the theorem of parallel axis and perpendicular axis. Secondly, we will be defining torque and find the direction of rotation produced by it. We will also be discussing about principle of conservation of angular momentum and calculate the velocity acquired by a rigid body at the end of its motion on an inclined plane. Let us see what is the moment of inertia in these different shapes and different axes that the bodies are having. First, let us take up an example of hoop, and we take a hoop rotation about a central axis, that is an axis that is passing through the center of the hoop. The moment of inertia for this is given by I is equal to mr square. Similarly, we can take up an annular cylinder or a ring, and the cylindrical axis has been chosen as the rotational axis. The value of moment of inertia comes out to be I is equal to m by 2 in brackets r1 square plus r2 square. Then we have an example of solid cylindrical shape object in which the cylindrical axis is taken as the moment of inertia that we are calculating about the rotational axis, and the value of moment of inertia comes out to be I is equal to mr square by 2. For the solid cylinder, if we take out the value of moment of inertia about an axis that is passing through the central diameter, we get the value as I is equal to mr square by 4 plus ml square by 12. Now we are going to find out the moment of inertia in the rod in which the arc axis is passing through the center and normal to its length. The value of moment of inertia comes out to be I is equal to ml square by 12. Similarly, if the thin rod has an axis passing through one of the end and perpendicular to the length, then we have the moment of inertia as ml square by 3. If we take a solid sphere and the rotational axis is about diameter, then I is equal to 2 by 5 mr square. We also observe that when we calculate the moment of inertia of a thin spherical shell about an axis passing through any of the diameter, we get the moment of inertia as 2 by 3 mr square. Similarly, moment of inertia for a hoop where axis is passing about any diameter is given by mr square by 2, and the moment of inertia for a hoop when the axis is passing through a tangent line is given by 3 by 2 mr square. Now we will discuss about the theorems of moment of inertia. There are two theorems which connects moment of inertia about two axes, one of which is passing through the center of mass of the body. First theorem is theorem of parallel axis, and the second theorem is theorem of perpendicular axis. The theorem of parallel axis. The moment of inertia about an axis parallel to the axis passing through its center of mass is equal to the moment of inertia about its center of mass plus the product of mass and square of the perpendicular distance between the parallel axes. That is, I is equal to IC plus MD square, where I denotes the required moment of inertia, IC is the moment of inertia about a parallel axis passing through the CM, and m is the mass of the body and d is the distance between the two axes. Let us talk about the theorem of perpendicular axis. For this, take a lamina in which there is three axes x, y, z, and when we have to calculate the moment of inertia of a hoop, we have the hoop is being denoted by a circle. There are two values, that is id, that is a moment of inertia about a diameter which is passing through the center of the circle is given as id. When we rotate it by an angle 90 degree, again we have a diameter which is given by id. So, Iz is equal to Ix plus Iy according to theorem of perpendicular axis. The perpendicular axis theorem states that the sum of the moment of inertia about x and y axis is equal to the moment of inertia about the z axis. Take an example of hoop. That is, the moment of inertia of a hoop about an axis passing through its center and perpendicular to the base is given by mr square, where m is its mass and r is its radius. According to theorem of perpendicular axis, this must be equal to the sum of moment of inertia about the two diameters which are perpendicular to each other as well as to the central axis. The moment of inertia of a hoop is given by Iz is equal to Ix plus Iy. Iz is given by mr square, while Ix is equal to Iy, which is given by twice of Id. Since the moment of inertia about each diameter is same, that is Id, therefore, the moment of inertia of a hoop about any of its diameter is given by mr square by 2. Let us talk about torque and couple. The question arises, what is the analog of force in the case of rotational motion? To look into this, consider the example of opening and closing of a door. A door is a rigid body which can rotate about a fixed vertical axis passing through the hinges. What makes the door rotate? Well, can any force rotate the door? No, any force does not rotate the door. A force applied on hinges does not rotate the door, but the force applied at the right angles to the door at the outer edges is most effective in producing the rotation. This is a point that is to be noted. It is not the force alone, but how and where the force is applied is important in rotational motion. And the rotational analog of force is the moment of force. It is also referred to as torque or couple. The turning effect of a force is called as torque. Now, we will discuss about the torque by taking an example of a body, rigid body, and rotated it by angle of theta. For this, let us take up the figure that is shown on the board. This is a body which is a lamina we have taken, and there is a point which is being fixed, that is a nail has been put on this thing. A body can be rotated by applying a force. We are applying a force that is at a point A. So, we can see that when we join the action of the force line, that is A, it goes up to B, and then there is a distance S between O and B. So, between the fixed point O and along the force which is being applied along this action line AB, there is a distance S, while between the fixed point O and the force applied at a point A, this is called as a distance R. The question is, if we apply the same force here, that is at a point O, will it be rotate the body? What we notice that when the force is applied here, no rotation occurs. But certainly, when a force is applied at a point A, the body rotates. What is the reason for this? Since torque is given by F into S, that is the force applied and the distance between the line of action and the fixed point. But this S, it can be seen it is equal to R sin theta. So, we have tau is equal to R cross F, because R cross F, when we remove the cross, we have RF sin theta. This means this is a special significance, this carries a special significance. Why? Because now the torque has a direction perpendicular to the plane containing R and F. The unit of torque is Newton meter. Now what happens? There are two cases, when the torque is 0 and when the torque is maximum. That is, in this case you can see when the torque is 0, the theta is equal to 0. That is, there is this theta, it is 0 between the point that is we are taking, and tau is equal to 0. When the theta is 90 degree, we have tau is equal to RF and it has the maximum value. Therefore, we have also gained that there is a right hand thumb rule in which the direction of torque is given by this thumb, and there is R and F plane. If they are rotated, this direction gives the direction of the torque. We can take up another example. Here we have taken a laminar body. We apply force, that is two equal and opposite force. This is in the right direction and this is in the left direction. There is another point to be noticed, that the line of action is different. that it has been applied at this point B and this force has been applied at point A. This lamina has been fixed up at a point O. There is a difference in the distance, that is where the point F is applied at B, it is at a distance A from the point that is O, and force that is being applied at point A, it is at a distance A plus B. So, according to our definition of torque, torque is given by Fs, that is the force applied and the distance between the axis of rotation and the action line. Therefore, we have tau 1, that is tau 1 is given by for this force as A plus Bf. Why? Because the distance is A plus B. While for torque 2, that is for this thing, we have the distance being A and then we have F. So, it is equal to F. We will calculate the net torque applied on this lamina. This is equal to tau 1 minus tau 2. What do we get? We get Bf. Therefore, the magnitude of net torque is in the direction of the larger torque. That is, there it is a larger torque, here it is a smaller torque. Therefore, the net torque is applied in the direction of the larger torque. Also, we have two equal and opposite forces acting on a body having different line of action. It forms a couple, and couple whose torque is given by this value. Now, we will also consider to explain more about the value of torque in terms of angular acceleration. Let us consider a rigid body rotating about an axis passing through the point O. Let us take up this is a point O. Here is an interesting thing. We take up a particle P on this lamina. When this body is rotating about this point O, about this axis OA, then this particle P is rotating about an axis in a circle of a radius r. Again, if the motion is non-uniform, that is the circular motion is not uniform, then there are two forces being applied on the body. First, the radial force, that is being applied in this direction, and then the tangential force which is applied in this direction, that is tangent to the circle. This radial force, it does not produce torque, again because theta is equal to 0, and it is equal to the centripetal force of attraction, which is always attracted toward the center, given by the value mr omega square. While the tangential force which is responsible for the change in the velocity is given by ma, because the change in the velocity with time will give you acceleration. A is called as tangential acceleration, and it is again related to angular acceleration by r alpha. Alpha is the angular acceleration and r is the distance between the particle and the axis of the rotation. Therefore, we are saying that the torque is equal to the force, that is the tangential force, into the distance, that is r. It is given by mi ri square alpha. Again we know that the expression summation mi r square represents moment of inertia. Therefore, the torque is given by I alpha. Hence, I is the moment of inertia, alpha is the angular acceleration produced, and torque is related to both of them by this expression. Let us talk about angular momentum. Get hold of a stool which rotates without friction. Now measure the speed of the stool when a person with arms folded sits on it and rotates. Also measure the speed when the person rotates with the arms stretched. We notice that the stool moves with a greater angular velocity in the first case, that is, in which the person sits with the arm folded, and the product of the linear momentum and the distance from the axis is called as angular momentum, denoted by L. L is equal to I omega, where omega is the angular velocity and I is the moment of inertia. The angular velocity omega is same for all the particles and I is the moment of inertia. Above equation gives only component of vector L along the axis of rotation. The unit of angular momentum is kilogram meter square second inverse. Let's talk about the conservation of angular momentum. First, we should know that the rate of change of angular momentum is equal to torque. That is, dl by dt is equal to torque. Since torque is equal to I omega, therefore we have I d omega by dt, which is again equal to I alpha, where alpha is angular acceleration. What happens if dl by dt is equal to 0? That is, torque is equal to 0, which means that no torque is acting on the body. This means that there is no change in L and angular momentum remains constant. This is called as the principle of conservation of angular momentum. Let's talk about the examples of conservation of angular momentum. The first example is when the person rotates with the hand folded, then the moment of inertia decreases because the distribution of mass decreases and the angular velocity increases. Why? Why the angular velocity increases? Because according to the law of conservation of momentum, L is equal to I omega. So, if the moment of inertia decreases, then angular velocity increases to keep the angular momentum constant and conserved. Another example is that the length of the day is not constant. And what are the factors responsible for this? Well, the earth is rotating about its axis and its moment of inertia changes because there is a change in the distribution of mass of air which happens due to changes in the weather. So, angular velocity changes due to change in the moment of inertia, and since L is equal to I omega, so the length of the day changes. Let us talk about simultaneous rotational and translational motions. For this, imagine a motion of an automobile wheel on a plain horizontal surface. We see a circular face, and when we fix our attention on a point C and P, we notice that point P rotates around the point C when the wheel rotates. Well, the point C itself gets translated in the direction of the motion. So, wheel has both translational and rotational motion. If point C or center of mass gets translated with velocity Vcm, the kinetic energy of translation is given by kinetic energy translation is equal to half mvcm square, where m is the mass and if omega is the angular speed of the rotation, then the kinetic energy of rotation can be written as kinetic energy rotation is equal to I omega square by 2, where I is the moment of inertia. So, the total energy of the body due to translation and rotation is the sum of two kinetic energies. Let us talk about the secret of pulses. It is an interesting example of the conservation of angular momentum. The stars send pulses of radiation of great intensity towards us because stars are rotating very fast. The time period for the pulse received range from a few milliseconds to few seconds. The stars that we are talking of consist of neutrons and they rotate very fast because of their tiny size. The radius of the neutron star is 10 km, while the radius of sun is 7 into 10 raised to the power 5 km and it rotates about its axis with a period of 25 days. Imagine that now sun suddenly shrinks to the size of neutron star without any change in its mass. In order to conserve its angular momentum, the sun will have to rotate with a period as short as fraction of millisecond because now its distribution of mass has changed. It has been shrinked, that is the radius decreases. So, now let us see what we have learnt in this chapter. We have learnt about the turning effect of force on a rigid body which is given by torque. Two equal and opposite forces constitute a couple. The magnitude of turning effect of torque is equal to the product of one of the forces and the perpendicular distance between the line of action of forces. The application of an external torque changes the angular momentum of the body. And when no net torque acts on a body, the angular momentum of the body remains constant. Thank you.
NIOS के जरिए नेशनल इंस्टीट्यूट ऑफ ओपन स्कूलिंग या राष्ट्रीय मुक्त विद्यालयी शिक्षा संस्थान, इस संस्थान का एक बड़ा उद्देश्य है आम आदमियों के जीवन को बेहतर बनाना। ऐसे लोग जिनके लिए शिक्षा एक दूर का सपना है या वे बच्चे जो परिवार की रोजी रोटी कमाने के लिए बीच में ही स्कूल छोड़ने पर मजबूर हो जाते हैं। NIOS ऐसे बच्चों और बड़ों को दोबारा शिक्षा से जुड़ने का मौका मुहैया कराता है ताकि वे एक बेहतर जीवन जी सकें। 1989 में स्थापना के बाद NIOS ने देश के लाखों बच्चों और वयस्कों को बेहतर शिक्षा से जोड़ा है। इनमें हर उम्र, हर पृष्ठभूमि, हर जाति, हर मजहब और हर क्षेत्र के लड़के लड़कियां, महिलाएं और पुरुष शामिल हैं। बढ़ई से लेकर पायलट, डॉक्टर, इंजीनियर, बेकर और दर्जी तक NIOS कोशिश कर रहा है सबको शिक्षित और सशक्त बनाने की, चाहे वो असम के दूर दराज इलाके में रहने वाला हो या फिर मुंबई जैसे महानगर का। NIOS ने अपनी मौजूदगी हर जगह दर्ज कराई है। NIOS ने शिक्षा की परंपरागत सोच को ही बदल दिया है। वो पढ़िए जो हम पढ़ाते हैं की जगह NIOS की नई सोच है, हम वो पढ़ाते हैं जो आप पढ़ना चाहते हैं। इस नई सोच ने लोगों को आगे बढ़ने और NIOS के साथ जुड़ने के लिए प्रोत्साहित किया है। शिक्षा उपलब्ध कराने के मामले में NIOS किसी सीमा को नहीं मानता, उम्र की सीमा को भी नहीं। चंडीगढ़ के गणेश के लिए भी NIOS एक वरदान साबित हुआ। NIOS शारीरिक रूप से अक्षम बच्चों को भी बेहतर शिक्षा मुहैया कराने के लिए पूरी तरह प्रतिबद्ध है। ऐसे बच्चों के लिए शिक्षा न केवल रोजगार के द्वार खोलती है, बल्कि उन्हें आत्मविश्वास और गर्व के साथ जीना भी सिखाती है। NIOS खेल के इन सितारों को उनकी सुविधा और समय के अनुसार बेहतर शिक्षा उपलब्ध कराता है। मेरी कॉम, सोमदेव देववर्मन, देविका रेबेका पल्लिकल, अरमान इब्राहिम, प्रद्युमन प्रकाश और अमयजोत सिंह। NIOS सीमा पर खड़े उन प्रहरियों को भी शिक्षा से लाभान्वित करता है जो देश की सुरक्षा के लिए अपनी जान की बाजी लगाने से भी नहीं चूकते। सच तो ये है कि NIOS की पहुंच हर ओर रहती है, चाहे वो दूर दराज के आदिवासी हो या जेल की कोठरी में बंद कैदी या फिर ग्रामीण और शहरी क्षेत्रों के गरीब निवासी। देश में कहीं भी कोई भी व्यक्ति, स्त्री, पुरुष, लड़का, लड़की, अमीर, गरीब शिक्षा से वंचित न रहे। राष्ट्रीय मुक्त विद्यालयी शिक्षा संस्थान का यही मिशन है।
राष्ट्रीय मुक्त विद्यालय शिक्षा संस्थान पूरे देश में शिक्षा के साथ साथ कौशल विकास के क्षेत्र में बहुत सारे कोर्सेज दे रहा है। लगभग 100 से ज़्यादा कोर्सेज हैं। हम दूर दराज के गांव में अपने संस्थान बनाते हैं और वहाँ के बच्चों को, वहाँ के बच्चियों को, वहाँ के वयस्कों को हुनर के क्षेत्र में शिक्षा पहुँचाते हैं। आपको जानकर खुशी होगी कि अब हम आर्ट्स, साइंस, कॉमर्स जिन क्षेत्रों में 12वीं का सर्टिफिकेट दिया जाता रहा है, अब हम हुनर के क्षेत्र में, वोकेशनल एरिया में भी 10वीं और 12वीं का सर्टिफिकेशन करेंगे। तो वो बच्चे जो कृषि से जुड़े हुए हैं, कारपेंट्री से जुड़े हुए हैं या दूसरे क्षेत्रों से जुड़े हुए हैं, वो अपने ही क्षेत्र में काम करेंगे, सीखेंगे, हुनर पैदा करेंगे अपने में और सर्टिफाइड भी होंगे कि वो सर्टिफाइड कृषक हैं, खेतिहर हैं। तो आज तक जो हमारे देश में ये सोच रही है कि आप 12वीं पास तभी कहे जाएंगे जब भूगोल, अर्थशास्त्र, भौतिकी ये पढ़ेंगे, अब ये समय बदल गया है। ITI में जितने बच्चे पढ़ते हैं, लगभग 18 लाख बच्चे हर साल दाखिला लेते हैं। अब हम उनको सर्टिफिकेशन करेंगे।
NIOS अपने छात्रों को माध्यमिक स्तर पर 26 और उच्च माध्यमिक स्तर पर 19 विषयों का विकल्प देता है। पढ़ाई किस माध्यम से करनी है, इसमें भी आपको लचीलापन मिलेगा। माध्यमिक स्तर पर ही 7 भाषाओं के अलग अलग माध्यमों का विकल्प मौजूद है। शैक्षणिक कार्यक्रमों के अलावा 86 वोकेशनल शिक्षा कार्यक्रम भी उपलब्ध हैं, जो छात्रों को कामकाजी दुनिया के लिए तैयार करते हैं। वोकेशनल प्रशिक्षण को अधिक सुदृढ़ बनाने के लिए NIOS ने ITDC, सिस्को, इंडियन मेडिकल एसोसिएशन जैसे कई सरकारी और गैर सरकारी संस्थानों के साथ भागीदारी स्थापित की है। आज लाखों छात्रों के लिए अपनी पसंद का स्कूल है राष्ट्रीय मुक्त विद्यालयी शिक्षा संस्थान यानी नेशनल इंस्टीट्यूट ऑफ ओपन स्कूलिंग। NIOS ने एक लंबा सफर तय किया है, लेकिन मंजिल अभी दूर है। निरंतर विकास और नवीनीकरण के लिए NIOS सदैव प्रतिबद्ध है। शिक्षा का उद्देश्य महज रोजगार जुटाना ही नहीं है, बल्कि स्वयं को सशक्त बनाना भी है। NIOS लाखों छात्रों के लिए यही आत्मसम्मान दिलाने में जुटा है। लाखों लोगों के लिए एक आशा और उम्मीद है। नेशनल इंस्टीट्यूट ऑफ ओपन स्कूलिंग। शिक्षा सबके लिए, कहीं भी, कभी भी।
हिंदुस्तान के हर कोने में नौजवानों के पास प्रतिभा है, उन्हें अवसर चाहिए।
NIOS देता रहा है युवाओं को अवसर आगे बढ़ने का। NIOS से पढ़ने वाले इन युवाओं ने किया है संस्थान को गौरवान्वित। दिव्यांगों ने बन के दिखाया है सबल और आत्मनिर्भर। NIOS के साथ आप भी जुड़िए NIOS के संग।
जीवन ये प्रकाशित करने, राहों को आलोकित करने, हम अपना दीपक स्वयं बने, हम अपना रास्ता स्वयं चुने।
सीमा से विद्यालय जो मुक्त हो, संसाधन समय की सीमा से विद्यालय जो मुक्त हो।
कभी पढ़े हम कहीं पढ़े, वे विषय के